Now if we have a look at question 3, we see that we are given question 3. We see that we are given an arithmetic series, or an arithmetic sequence rather, of the following: -3, 1, 5, and then the last term 393. Question 3.1.1 says determine the formula for the nth term of the sequence. So for the nth term of the sequence, that would mean that we know that it's an arithmetic sequence. An arithmetic sequence, the formula for that is a plus n minus 1 times d, where we know that a is your first term, which in this case is -3. And d is your common difference, so term 2 minus term 1, and in this case 1 minus -3 is 4. Yeah, so we can just fill that in here. Tn equals a, which is -3, plus n minus 1 times common difference, which is 4. And we just multiply that out and solve for it. We get -3 plus 4n minus 4, and our final answer would be 4n minus 4 minus 3, 4n minus 7. There you go. That's your solution for your nth term of this sequence. Next question, 3.1.2, just asks us to write down the next couple of terms in the sequence. They want term 4, term 5, term 6, and term 7. Term 4, term 5, term 6, and term 7. Now the easy way to do it, because we can see it's an arithmetic sequence, we see the common difference is 4, so you just add 4 to every term. So from term 5, the next term would be 5 plus 4 is 9, plus 4 is 13, plus 4 is 17, plus another 4, 21. And that's your answer. You could also work it out the long way, which would still be right. We can say that, for instance, term 4 is equal to, we know it's -3 plus n minus 1, so 4 minus 1, times common difference, which is 4. That is equal to -3 plus 4 minus 1 is 3 times 4, so that's 12 minus 3 equals 9. And you see it corresponds exactly to what we just said from adding 4 each time. So that's another way to do it. Okay, and that's your answer for the next 4 terms. Next question, 3.1.3. Write down the remainders when each of the first 7 terms of the sequence is divided by 3. Okay, so we know that what the first 7 terms are. Let's just write them down there again. Term 5, term 6, and term 7. Okay, so the terms are -3, 1, 5, 9, 13, 17, and 21. And now they want the remainder when each term is divided by 3. So -3 divided by 3, 1. So the remainder is 0. 1 divided by 3, 0 with a remainder of 1. 5 divided by 3 is 1 with a remainder of 2. 9 divided by 3 is 3, so there's no remainder. 13 divided by 3 is 4 with a remainder of 1. And the pattern continues. 17 divided by 3 is 5 with a remainder of 2. And 21 divided by 3 is 7, so there's no remainder. You can see it goes with the pattern 0, 1, 2, 0, 1, 2, 0. And it keeps going. Now, the next question follows on from here, 3.1.4. This question states, calculate the sum of the terms in the arithmetic sequence that are divisible by 3. So those are only the terms that have a remainder of 0, because for something to be divisible by another number, the remainder, when the division takes place, has to be 0. Okay, so that means that only every third term is part of this new sequence that we now have. So it will be term 1, term 4, term 7, all of those numbers would be involved. So it's every third number, which means only 1/3 of the total number of terms would be left in the sequence now. So let's see what the total number of terms was initially. We knew it started at -3, and then it went up to the term which was equal to 393. Now to find out how manyth term that is, we'll just set Tn equal to 393. And then we'll say that 393 is equal to 4n minus 7, which, as you can remember from the previous page here, that was our general rule for the nth term. And now we'll just solve for n. Take the 7 across, so we get 400 equals 4n, which means that there are 100 terms. Now I want to find out what a third of 100 is. So 100 divided by 3 is 33 terms. So it'll give us 33, but then there's a remainder of 1, the last number. So is this last number, is that divisible by 3 or not? 393 divided by 3 is 131. It is divisible by 3. So 33 plus that last term is equal to 34. So that's how many terms there are in this new sequence now, in the sequence of terms divisible by 3. And they're asking us to find the sum of this series. So the sum to the first n terms in an arithmetic sequence or series has the following formula: n over 2, 2a plus n minus 1 times d. Okay, so what do we know? We know there's 34 terms, so the sum to 34 terms equals 34 over 2 times the first term, which is -3, plus n minus 1, 34 minus 1, times the common difference. So what is the common difference now? It's no longer 4. Let's see. Term 1, that's the first term in our current series. And then, which is the next remainder of 0, 9. So 9 is our second term. So our common difference is 9 minus -3, which is 12. So that's now our common difference. Okay. The sum of the first 34 terms is equal to, if you calculate that, 34 over 2 is 17, and that becomes -6. Let's just write this out. 17, -6, plus 34 minus 1 is 33, times 12 is 390, and therefore we have that the sum of the first 34 terms is equal to 396 here, minus 6 is 390, so 390 times 17, 6,630. There we go, that's the sum to the first 34 terms of this sequence. Okay, let's go on to the next question. 3.2. Now for this one there's a picture that you'd need to see. I'll draw a quick rough one, but you can look at the paper yourself. This is another pattern, but it has figures. So this is figure 1, is 1 dot. Figure 2 is a pentagon. Figure 3 is a larger pentagon with a small one inside of it. So there's a small one inside of it, and then it goes down. And then there's another one that's slightly bigger. I won't draw the next one, it'll waste too much time. So this is figure 1, figure 2, figure 3. And then there's a fourth figure inside which continues this pattern. Now the question 3.2.1 asks the following. If Tn represents the total number of dots in figure n, then Tn equals 1, T1 equals 1, T2 equals 5, and the pattern continues in this manner. They ask us to determine T5. So what is T5 equal to? Yeah, we can see from this figure, figure 1 is 1, figure 2 is 1, 2, 3, 4, 5. The third one, term 3, is equal to, okay, that's your 5 from the previous picture, and then we just add 6, 7, 8, 9, 10, 11, 12. So that's got 12. And then the fourth figure would have, I'm not going to draw that picture now, but the fourth figure would then have 22 dots. And you can continue drawing this yourself. The only thing you do is add one line here, one line there, extend it down, and connect it again. Okay, so now we've got enough information to find a pattern. Let me rewrite this in horizontal form. Okay, so term 1 is 1, term 2 is 5, term 3 is 12, and term 4 is 22. Okay, and they ask us, what is term 5? So first of all, let's find a general equation for this. Okay, so first of all, we see it doesn't increase by the same margin every time. So it's not a basic arithmetic series. Let's see if it's a geometric. Geometric would be at the same ratio each time. So 1 times 5 is 5, times 5 is 25. Okay, so it's not geometric. So it's probably going to be quadratic. Let's have a look. The difference between these two terms, 4, between those two, 7, between these two, 10. So there's difference between the differences, 3, 3. That's common. So because they're even, we know it's a quadratic equation, quadratic sequence. Quadratic sequence has the form an squared plus bn plus c, where 2a is equal to the common difference, which in this case is 3. We know that 3a plus b is equal to that first difference. Let's just call it the first difference. And we know that a plus b plus c is equal to term 1. Yeah, now let's substitute that in. So we know that 2a is equal to the common difference, which is 3. That means that a is equal to 3 over 2. Okay, we know that 3a plus b is equal to our first difference, which is 4. So that means b is equal to 4 minus 3 times 3 over 2 is 9 over 2. So 4 minus 9 over 2 is 1 over, let's just take 9 over 2, negative 1 over 8. Okay. Negative 1 over 2, sorry. My apologies. And to find where our c value is, we'll say that a plus b, which is plus negative a half, plus c is equal to term 1, which is 1. Okay, so c equals 3 over 2 minus a half is 1. So 1 minus 1 is 0. So c is 0. Now in terms of this, we've got Tn equals a n squared plus bn, which is negative a half n, plus c, which is 0, so we can just leave that out. And there's your general equation. Now we want to put 5 into that equation. Find term 5. Okay, so we have our basic equation now. Tn equals 3 over 2 n squared minus a half n. We need term 5. So term 5 is equal to 3 over 2 times 5 squared minus a half times 5. That is equal to, 5 squared is 25, times 3 is 75 over 2, minus half times 5 is 2.5. Let's just call it 5 over 2. And that's equal to 75 minus 5, 70 over 2, which is equal to 35. So that's your term 5. Next question, 3.2.2. they ask us what is term 50. Well, we'll use the same approach. In the previous question, if you didn't want to calculate this whole pattern or equation first, that formula, you could have just drawn the figure and see what happens, or you could have gone on with this pattern. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13. 3 is 13. So 22 plus 13 would be 35. That would be another way to do that question. But now we already have this formula, so we can just work out T50, and that is equal to 3 over 2 times 50 squared minus a half times 50. Okay, 50 squared is 2,500 times 3 is 7,500 over 2 minus half times 50 is 25. Okay, 7,500 divided by 2 is 3,750 minus 25, 3,725. There you go, that's term 50. And that's it for question 3.